In this video, I'd like to show you how you can use the statistics calculator in order to come up with normal distribution probabilities for the central limit theorem, which are just normal distribution probabilities, but the standard deviation is affected by the sample size. So we would still go under the distributions menu and still to normal. And in this case, we have let's read the problem. Population of values has a normal distribution with mu equals 176.8 and sigma equals 70.4. You intend to draw a random sample of size n equals 189. So find the probability that a single randomly selected value is less than 161.4. Okay, so we have a mean of 176.8 and a standard deviation of 70.4. Let's input those, press the update button, and you'll know that that's in because you'll see the axis change with new values that are made from these numbers here. All right, now we want to find a probability that a single value is less than 161.4. So it's an area to the left because it's less than 161.4. And what I would do is move this down to 161.4, but again, it's kind of hard to get it exactly where it needs to be. So what I would recommend is just type in the value. That's why I made that an input box. And then it will come up with exactly what you need. All right, so 0.4134. Now, here's where the central limit theorem comes in. So find the probability that a sample of n equals 189 is randomly selected with a mean less than 161.4. So when we have a sample of 189, what happens is the standard deviation is reduced by a factor of the square root of that number. Now you could come over to the calc menu and you could take not 176, but 70.4 it was. You could take 70.4 divided by the square root of 189, and that would give you about 5.12. You don't want to round that off if you do it this way. Take this full number and then enter it as your new standard deviation. But there's a nice feature here that I put in where the standard deviation, it will do a calculation for you. So you can type in 70.4 divided by the square root of 189, then press the update button, and it won't change it into a number, but you'll see these values update. And if you'll notice, these are off by about 5.12, which is what the standard deviation was. So it does this calculation and saves the new numbers. Now, sometimes the inputs get a little bit messy. You'll see this NaN showing up, but if you move things around or just change the input, it often will correct itself. All right, but we still want areas to the left, and we're now looking for the area to the left of 161.4, but subject to this new standard deviation. So I could move my cursor down, or move this point down to that point, or I could just type in 161.4 and calculate. And notice it's 161.4. That point's really close to that value, so that makes sense. And there's the associated probability. So that's the shaded region, but we're not really seeing much of a shaded region just because it's so far away from the mean. So 0.0013 it looks like. And let's submit. Very good.